My name is Hema Hendrik with matrix number AF190177, and now I would like to present about the introduction of our project. 1.1 Slope failure. Slope failure is a surface soil which is inclined and causing a sudden collapse of soil due to instability. Slope failure occurs when driving forces overcome resisting forces. The driving force is usually a gravity, while the resisting force is the shear strength of slope material. This phenomenon has caused many destruction to human beings and environment. There are many people lost their lives, property damage, and economic disadvantage. There are two possible ways of slope failure will occur, which is natural and man-made forces. Natural events refer to failure due to earthquake, weathering, groundwater, and rainfall, while man-made refer to activities such as excavation, infrastructure project, road cutting, and embankment. Next, 1.2, which is issue in engineering practice. Geotechnical engineering practice is really important for a better performance of design. Surface and subsurface exploration is need to be done in this practice in order to obtain and investigate all information related to the behavior of earth, materials including the physical, mechanical, and chemical properties of rock and soil. In Malaysia, slope failure is resulted by the design, construction, and maintenance error or human error based on Jamaluddin 2006. Slope failure in Malaysia are mostly due to the human mistakes or error where they are not competent enough, negligence, and poor maintenance system which lead to improper construction and design based on Kazmi 2017. It also shows that 57% of slope failure occur due to human error and only 29 and 14% are due to physical and geological factors. Next, 1.3, which is type of slope failure. The understanding of types and causes of slope failure is really important and useful in order to design slope or the remedial work. There are many types of slope failure in soil, which are translational failure, rotational failure, flow failure, and block failure. Translational failure is a failure that occurs along a weak zone of soil. This failure will occur when the slope is in an infinite slope, causing a parallel slip surface formed by the topsoil. Infinite slope is when there are no definite boundaries around the slope and the identical depths and properties of soil under the free surface are same as the slope. Translational failure is usually happen in coarse-grained soils. Next, rotational failure. Rotational failure is an outward and downward movement of fell surface. This is due to the slope surface begin to curve because of the rotation by slip surface. Rotational failure can be categorized into three, which is base failure, toe failure, and slope slide. This failure is common happen in fine-grained soils. Next, flow failure. Flow failure is when the soil forced to act as viscous fluid due to the external and internal conditions, then will flow down to shallow slopes and spreading out in several directions. Flow failure can occur in both dry and wet conditions of soil. And the last one is block failure. Block failure occurs when a shattered mass moves as block and wedges down the slope. When slope is constructed from two different non-compatible materials, the soil will contain weak layer causing soil mass is shattered along weak zone forced from adjacent soils. This failure also known as wedge failure and can occur in both infinite and finite slopes.
Hi everyone, my name is Muhammad Kamal Arif, CF190018. I'm here to talk about literature review. What is slope failure? Slope failure is a complex geohazard that has negative consequences on the environment and socio-economic aspects. The increased cases of slope failure are associated with rapid infrastructure development and to hilly terrain. The investigation of slope failure usually requires boreholes to obtain information on the mechanical and hydraulic characteristics of the study area at a specific point of the subsoil. In order to overcome this problem, the application of the in-situ geophysical method has become a prime choice in providing continuous information which is incorporated on a greater soil volume beside offering a non-destructive method. The first one is technique of slope remediation. And the second one is construction technique of slope stability remediation. And the third one is theory for slope stability analysis. I will talk all about this. Technique of slope remediation. Retaining structure method, which is retaining wall. Retaining walls are relatively rigid walls used for supporting soil laterally so that it can be retained at different levels on the two sides. Retaining walls are structures designed to restrain soil to a slope that it would not naturally keep to. Retaining walls idea are useful when you know the type. So here are some retaining walls type. Okay, the first one is gravity wall. Gravity retaining wall depends on its self-weight only to resist lateral earth pressure. It is commonly massive because it requires significant gravity load to counteract soil pressure. The second one is cantilever retaining wall. The structure of the cantilever retaining wall, as we can see in the figure, contains the slab of concrete, which is covering the area below the backfill as well. In this retaining wall, the structure is specifically made up of concrete, and due to that, it is economic till the extent of height 10 meters, and above that, it can be proven to be expensive. And the third one is creep retaining wall. Creep retaining walls are retaining walls whose construction can be built on the site or elsewhere and then installed on the site. This retaining wall concept is mostly used to regulate soil pressure in the mountain and to construct roadway when the mountain soil is semi-vertical in angle. Okay, the next one is construction technique of stability remediation. The following are the most often utilized slope stabilizing technique. The first one is geometrical technique, brings change in the geometry of slope. Hydrological technique lowers the water content of soil or rock material by reducing the groundwater table. And the third one is chemical and mechanical technique. Increase the shear strength of the critical plane of soil or rock mass by minimizing the external force triggering the slope failure. The next one is theory for slope stability analysis. In its design life, slope stability analysis serves a few objectives as follows. Recognize how natural slope evolve and take shape as well as the mechanism that cause various natural features. Determine the stability of slope in both short and long-term situation during building. Determine whether there is a risk of landslide on natural or constructed slopes. Investigate landslide and learn about failure mechanism and environmental influences. If necessary, redesign failed slope and plan for the creation of preventive and repair measures. Investigate the effects of earthquake on slope and embankments. That's all for me. Thank you.
Hi, my name is Melvin Gorket Heng with matrix number AF190103, and I'll present the technique of slope stability. For our project, we have chosen gravity retaining wall to stabilize the slope as it is the simplest and earliest recorded retaining wall. Due to its large weight, it can resist toppling and sliding, and its wide base and slope base can resist higher lateral earth pressure at depth. Next, I will explain the technique to remedial the slope failure. Step 1 is site prep and excavation. First, we need to remove surface vegetation and organic soils. Per approval plan, excavate base trench. Next, remove unsuitable soils and replace with compactable materials. And buried block should be a minimum of 6 inches. Check plans to see how much buried block is required. And compact and level trench. Next is stepping up the wall base. Walls built on sloping grade requires a step base, so we need to start with excavating from the deepest point and dig a level trench on the slope until it is deep enough to accommodate the base material and the entire block. At this point, raise the height of the block to start a new section of the base trench and continue to step up as needed to the top of slope. Last, always bury at least one full step unit at each step. And step 2 is install base material. Wall rock is placed in the base trench and raked smooth according to approved plans. Then we compact the level base material, and finally, proper base established is verified by site soil engineer. Step 3 is install base course. We'll start with the lowest retaining wall height. First, place the retaining wall block on the base material in the center of the trench and check and adjust the level and orientation of each unit. For retaining wall over 4 feet, drain pipe is required. See approved plans for location and specifications. Refer to design details on an alternate drain location. Step 4 is install wall rock and backfill materials. Hollow cores and behind the retaining wall are filled with wall rock. Approved soils is used to backfill behind the wall rock and in front of the base course. Use a plate compactor to consolidate the area behind the block and compact in lifts of 8 inches or less. And final step is to install additional courses. First, we will remove all excess material from top surface of retaining wall blocks. This can be done when installing the next course of block by sliding the block into place. Next, stack the next course of blocks so that the vertical seams are offset from blocks below by at least 3 inches or 1/4 the length of the block. Check and adjust for level, alignment, and the wall better as the retaining wall stacks up. Next, wall rock is used to fill the block core and behind the block. Approved soil is used to backfill behind the wall rock. From course 2 onwards, the plate compactor is used to directly compress the block and the area behind the block and complete the retaining wall to the required height. For more information on retaining wall finishing options, see finishing details. And finally, 8 until 12 inch of low permeable fill is used to fill on the last lift to finish off the wall. That is all for technique of slope stability. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Hakim bin Muhammad Hussein, and I will present to you the application of retaining wall. One of the most used retaining wall in Malaysia is the gravity retaining wall. The uses of gravity retaining wall is to help prevent erosion and also safeguard places from flood. The general specification used in Malaysia for retaining wall is British Standards 6031 Code of Practices for Earthworks and also British Standards 8004 Code of Practice for Foundations. And the Malaysian National Annex is used to help determine which code produces more critical design and also which code produces more economical design. That is all from me. Thank you very much.
Hi, have a good day, Doctor. Good morning. My name is Ivira Frederick Gan. Metric number is AF190024. Student Geotechnic 2. So today I'm going to present about long-term stability for retaining wall. So a permanent gravity retaining wall can endure anywhere from 25 to 100 years. And the most common type of retaining walls that are being used for holding the soil in various places like roads and hilly places. Why is drainage important to a retaining wall? Because water is the major cause of slope failures. For example, landslide. Water can trigger landslides because it alters the pressure within the slope instability. Consequently, the heavy water-landed slope materials like slope, rocks, and so on will succumb to the forces of gravity. In Malaysia, there are 4 types of maintenance inspection. Number 1, routine maintenance inspections, engineer inspection for maintenance, regular monitoring for special measures, and the last, frequent checks of subsurface water carrying service. So there are 6 slope management and engineering. Number 1, policies and legislation, undergraded modulus, structured training for practitioners. Number 4, slope maintenance. Number 5, construction quality control and site supervision. And number 6, planning, analysis, and design. That's all from me. Thank you. Have a good day, Doctor.
In conclusion, a gravity retaining wall is one of the best remedial work that can be used for slope failure to resist the lateral earth pressure acting behind them by using their self-weight. Gravity wall is the earliest retaining wall and easy to make. A significant gravity load is required in gravity wall in order to withstand the soil pressure. Eurocode 7 Geotechnical Design and the official publication of the Malaysian National Annex can be used for designing gravity retaining wall for economical design and better performance. It is said that gravity retaining wall can last for 50 to 100 years considering all elements in its construction. Lastly, slope failure is an issue that needs to be taken into account as it brings many disadvantages to all people where it also leads to loss of life. Therefore, a remedial work for slope failure is really important and necessary for the benefit of everyone. And that's all from us. Thank you.